Railway Conversations with Doc Frank.
Railway Conversations with Doc Frank.
Hello and welcome to another episode of Railway Conversations with Doc Frank. I'm your host of this podcast, Doc Frank. And today, for the very first time, I'm not having only one guest, but two, a double act from Stockholm in Sweden, Andreas Mårtensson and Gunnar Smith. Those two guys are specialists in formal methods. And if you don't know what formal methods are, what they are used for, and how they can help in a railway environment, then welcome to the club. I didn't know much about this either before the interview, but I learned a lot talking to those two guys, and I'm pretty certain that you can learn a lot about this as well once you listened to this interview. I hope you enjoy it. This podcast is not sponsored by third parties, but I do want to let you know that I'm offering training courses on modern railway signaling, the CBTC Kickstarter and the ETCS Kickstarter. They are called Kickstarter because they form the foundation of your knowledge of CBTC or ETCS, regardless of your prior level of signaling knowledge. So even if you are a complete signaling novice, you will be able to learn everything you need to know from this training. If you don't believe it, just sign up and you will see that I haven't promised too much. Information on these courses and also the opportunity to register is on my training portal, docfranktraining.podia.com. That's docfranktraining, one word, .podia, PODIA.com. I look forward to seeing you at one of those courses, and until then, please enjoy my conversation with Andreas and Gunnar. Andreas and Gunnar, welcome to the show.
Thank you.
Thank you.
I got your contact details from a common friend of ours from Denmark, and he said that you guys are the authority for using formal methods for CBTC projects. I'm not sure whether I understood this 100% correctly, but maybe you can start with a quick introduction of what you're doing, who you work for, and what your relationship with formal methods is, please.
Yes, so if I go first, my name is Gunnar Smith and I work with a company called Prover Technology, who is a supplier of services and products within this area of formal methods applied to the railway signaling domain. We apply this to both CBTC systems and mainline rail systems like ETCS and interlocking systems. And we've been working with Andreas Mårtensson for quite some time. So he's more on the user side. And Andreas, you can tell me a little bit more about that maybe.
Yes, my name is Andreas Mårtensson and I am employed at Stockholm Public Transport since 2009. And today I am an assistant signaling safety manager and working with technical requirements for our signaling systems too. And that was the reason why I came in contact with Prover, because we have an extension projects on one of our lines. So we have worked together since 2010, and today we have done a lot of different kinds of projects in railway signaling and using this kind of tools for formal verification of the interlockings and the safety functions. And then I was contacted by the common Danish friend as a reference for the Metroselskapet in Denmark. And he asked me if I could tell them if I have any experiences of this type of work, because they are thinking about that in connection to their expansion projects in Copenhagen too. So I started to speak with my friends and dig in my archives and think about what's the most important plus of using this kind of tools and how has it changed the signaling work at our company and our methods and so on. And that was quite interesting. So I found out that the largest conclusion of this was that the formal methods are usable during the complete life cycle of a signaling system, regardless if it's an old relay-based system or a modern multifunctional signaling system such as CBTC. So practice of this can be performed during requirements phase, procurement phase, implementation phase, maintenance phase, and dismantling phase 2. So we have used this tool both on modern computer-based interlocking and also on old relay-based interlockings for re-engineering too, and to investigate how the systems are work and what functions we have and so on. So it has been a very interesting journey until the day we have reached today.
Well, this is interesting because I initially thought, the way that our Danish friend described it to us was like formal methods is one of the next big trends in CBTC project delivery to make things easier and more straightforward and also more reliable when it comes to the verification of system designs. That was at least my understanding. So I'm quite surprised, and at the same time, I'm also quite delighted to hear that you are applying this not just for the modern technologies but you can apply it just as well for conventional signaling technologies where you need to do any changes. Very often you have a big change from the old conventional signaling to the new advanced train control technologies like CBTC and ETCS. And it's a bit like there's an old word and a new word, and the methods used in those two words are quite different. So hearing that this is something that can be used in both words is really, it's quite a positive thing, I find.
Yes, and I think it can be particularly used to kind of bridge the gap between those two worlds, because you have an old existing system and you want to migrate to a new system, and if it's not a completely greenfield project, you probably want to keep some of the functionalities and you want to do this stepwise. So you really need to understand how your existing system works and how to go from that to the new system. And that's also an area where you often run into issues in projects because it's very difficult to get understanding of the existing system and kind of convey that information on what you have and what you want to the suppliers of the new systems. So there I think formal methods can play a quite large role when it comes to specifying and evaluating and validating the requirements that you have both on the existing systems and the new ones. And that's also a little bit how it has been used in Stockholm. And historically, formal method has been used in the railway domain for quite some time, at least 30 years, maybe not that widespread. And it has in particular been used in the area of formal verification, where you want to verify that an implementation or a model of a system fulfills its safety requirements. So it has been used on the safety assessment or verification and validation side, where it's an complement to traditional safety activities such as testing and manual code reviews and so on. Because the benefit of this approach is, well, it can be automated by tools, and it also gives what we say 100% coverage. So unlike testing, where you will never know if you have tested enough, with a formal method-based verification instead, you have a computer program that actually proves that your system fulfills the safety requirements, so you don't need to worry about having tested it enough. So that's perhaps the most common application of formal methods in the railway domain. But now, when we move to more complex systems such as CBTC, we see an increasing need to use the formal methods in the requirement phase to analyze what systems you want and how they fit together and so on. So we kind of lift the formal method to a higher level where we work on the requirements. And that's also particularly important for a metro that wants to install a new CBTC system, to be able to explain to their suppliers what they want, to have a solid set of requirements that can be clearly expressed, and they know that these requirements fit together and give you a system that actually works.
Just from my understanding, and maybe that's a question for Andreas, in Stockholm, when you're talking CBTC, is this a greenfield application? So like completely new lines, metro lines with CBTC from the start? Or are you converting an existing brownfield signaling system to CBTC? What are we looking at?
For the moment, we are looking at the brownfield project, and we have had experience of this earlier. We have had a CBTC conversion project, but that was terminated because we don't reach the goals with the supplier. Today we are working with lifetime extension of the existing systems on the metro, and in the future we will go towards CBTC, but the path is not decided yet. We are investigational in the beginning to investigate how to do this in a convenient way and analyze the needs and so on. But during this period, until we have installed a CBTC or another new kind of signaling system in our metro, we need to prolong the lifetime of the existing systems. And here we have found that formal methods is a very strong tool to analyze the existing systems and to set up the requirements, both for an external supplier and for our own work, because we have a lot of consultants inside to perform this, and they are not so familiar with our system. They are coming outside, and of course they have experience from railway and so on, but the Stockholm Metro is Stockholm Metro, and it's a very odd system. It's a very old system designed in USA in the 1930s and so on, so the knowledge of it is limited. So we need to have a platform to start from, and here we have found that formal methods have supported us very well to find that platform.
Okay, how easy or how difficult did you find it is to explain your existing systems with formal methods? I mean, you first you need to have somebody who understands the existing system, so that's number one. But then you also need to have that somebody to be able to explain that knowledge in the language, but that's my understanding anyway, in the language of formal methods. So you need to understand the system, and you need to understand the tool that you're using. And that's a combination which is probably even rarer than just having someone understanding the system and just having someone understanding the method.
Yes, we are working with functional requirements and the technical requirements in plain text, understandable with each other, and we are working with a generic safety specification, we are working with an object model, and we are working with operational scenarios to describe the behavior of the system, or if you want to call it further, I speak about the system's DNA. It's the behavior of the system, it's the main functions and so on. We collect it in the DNA, and we can put that into the specifications, and then we can choose which platform we want to realize it on. If we want to realize it on a computer platform, on a relay platform, or whatever else. And we can also adding new functions or adjust the existing functions to meet the expectations of the systems. So, of course, it's a work to get understanding of the formal methods. It's very detailed specifications, and I have been met by the project managers and so on, and they say, we are setting functional requirements only. we cannot use this kind of small, detailed requirements because that's too deep in the system. That should the supplier do, and so on. And I say to them, if you don't have control of the small details requirements, how could you be sure that your top functional requirements are fulfilled? Because they are built up by the small pieces, the small requirements in the bottom, like the famous Lego pieces. You put them together with a very well-defined interface, and you can build whatever you want, but the pieces are very well-defined and very small from the beginning.
Mm. Yeah, I think there's a bit of a boundary, right? So you have this V model in systems engineering, which I'm sure both of you are very familiar with, and you have certain tasks that are clearly responsibility of the client side. So starting off with something like a user requirement specification, and then also the functional requirement specification, and then when it goes down to where the supplier takes over, that's basically the step from a functional requirements back into a system requirement specification. And I think the discussion with the operator that you just described seems to sit somewhere in the middle, where your colleagues basically think they're going into the depths of system requirement specification. This is where they say that should be the supplier doing that. Whereas you are basically saying what you want them to do is making the functional requirements, which is client responsibility, a little bit more detailed so that it really describes comprehensively all the functional requirements that you have, and not just being high level and then basically leaving it to the supplier how to interpret it. And there's room for interpretations. Is that kind of how you see it? I see Gunnar nodding, so maybe I'm kind of on the right track here.
Yeah,
yes, you are. Do you have any comments, Gunnar?
Yes, I think it's a good point, and it's definitely sort of a trade-off where to draw this boundary between the owner of the signaling systems and the suppliers. And it's also very important to make this somewhat more detailed, as you say, because otherwise it's very, very much open for interpretation, and you don't even know if it's possible to realize those high-level functional requirements because you might have contradicting requirements and so on. So there is a need to have some level of details. And also using the formal approach, you can actually quite easily build prototypes to evaluate these requirements. Of course, you don't have to go into all the details you do when you implement the system, but you can actually generate a model of the system that you can apply formal methods to, and you can simulate it and you can try it out so that you know that your requirements are sound and not contradicting each other, so that you know that the supplier will be able to realize the system. And that is, of course, also important to get a system where you can actually verify in the end that it has complied with these requirements. Because if you only sit down with pen and paper and write a set of functional requirements, it is very hard to get that completely right unless you do it very high level. And if you do it too high level, then it will be impossible in the end to verify actually that the system complies with those requirements, unless, at least if there are meaningful requirements, I would say. And also coming back to the question of the skill set that is needed for this, you mentioned, of course, you need to have someone who knows the formal method to apply, but you also need knowledge about the signaling system, and that is, of course, a challenge. But it's also something where I think a good tool set around this can actually help. Because that is one of the problems that we want to solve with formal methods, that you can have more documented know-how about the signaling system rather than just having this know-how in the minds of these very experienced signaling engineers who might retire in 5 years. So we do this by building these models of the system and providing simulators and tools where you can actually try this out and get an understanding of how these system works. So that is also a big big part of the work, but also of the benefits, I would say, to gain this know-how.
Yes, it's a very good spin-off that you preserve the knowledge of the system for the future.
I was just going to say this. I mean, this discussion triggers a lot of things that I could comment on, and certainly the conservation of the knowledge of signaling experts in your organization, which are about to retire. This is a biggie. This is a real big thing where you find that in many railway organizations, a lot of the most experienced signaling engineers are reaching their early 60s, if not more, and they are going to retire at some stage. And since you can't put them on a photocopier and clone them, you need to find a way how to extract the knowledge and make it available for the next generation. And previously, my suggestion for a problem like this was to basically have a young person sitting side by side with the older experienced guy and basically sucking up the knowledge in order over a period of a few years to become as much as possible as knowledgeable as the older person was, so that if the older one retires, then the young person can take over without too much loss of experience. And I'm just curious whether the description of that knowledge in formal methods can really be so comprehensive that that would be a solution to this problem in your experience, maybe, yeah. Andreas.
Yes, it is, because the requirements are so clear that you cannot misinterpret them. And that's also an important part of this, because you can make the safety visible. Traditionally, you have a person which is reviewing the code or the circuits and so on, and then based on their experience and education and so on, they say that this is a safe system. Okay, so good, so far so good. And then they sign the drawings or the computer files or so on. And everybody is relying on that. But with formal methods, you can show why the system are safe. You can show them exactly the requirements and show them that these requirements are fulfilled. So it's no doubt, and everybody can read it and see it. And that's a very big advantage too, because you demystify the signaling.
I'm a big fan of demystifying stuff. I can tell you that much. Yeah, in my trainings on CBTC and ETCS, particularly on CBTC, one of the big challenges there, which I'm tackling head on, is to demystify all the things around CBTC. Like, it's so terribly complicated, it's rocket science, and I mean, this is all rubbish. I basically offer trainings for non-signaling people, and they understand everything. There is one other thing that came to my mind the entire time. I just need to talk about this, which is the clarity of the specification in formal methods. From my experience in ETCS, for example, one of the big issues that's faced by suppliers to implement an interoperable ETCS is a difference in interpretation of standards. So the standards have been developed by UNISIG, which is an association of signaling suppliers. So you may say that all the suppliers were involved in writing down the standards. They've been working on this for, I think, 30 years by now, at least 25. It's probably it's getting close to 30 years, I believe. So there was plenty of time to make sure that those standards and specifications are written down in a way that's understandable by everyone. Yet it still happens time and again that different people look at the same written words and interpret them in a different way, based on their background, based on the capability of their specific products, which may be different between different suppliers. And those those differences, you can't even say this one is right, this one is wrong. They're just different. They just have different interpretations. And as an outcome of this, you often have interoperability problems between ETCS from different suppliers, which shouldn't happen. So the ERA, the European Railway Agency, is calling this debugging of the specification. So basically, whenever they come about such a difference in interpretations, they say, well, this is a bug of the specification. It's not clear enough. And then they work on clarifying that specification. Now, coming back to formal methods, my question would be, if you say formal methods is also a text-based method of describing it, how do you make sure that you avoid those different interpretations by different people reading it?
So I can try to answer that. And first of all, I must say this whole topic of standardization within railway signaling is a very, very interesting one. Probably deserves an episode of your podcast on its own. But and I think formal method is definitely something that can help there. So one advice is, of course, that when you build a specification, you should also build a model of the specification where you can actually try it out and see how it works, because otherwise it's very hard to get it right. But of course, we still have the problem that we need to have these that we sometimes call natural language specification, and then the formal specification, and those, of course, needs to match. But you should really then have this formal specification as sort of the actual specification. So you can read the informal specification, and if there is something there that is not fully clear, then you have the formalization of that specification in this formal language that you can also go into and read and see exactly how it's supposed to be interpreted. And in doing also this whole process of going from the natural language specification into this formal specification, you also sort out a lot of issues in the natural language specification.
So what you're saying, what I understood from you saying is, you've got basically two documents, right? You've got a specification in natural language, and you've got a specification in formal language. And by reading both of those documents, people would identify or disclose where they might have interpretation problems. Is that kind of correct?
Yes.
Okay.
And the formal specification, it's not only just requirement that you write, it's sort of also building a model of the system so that you can actually try it before you implement it.
How do you try that? I mean, a model, I think of a model something like you're writing computer code or so, and then you push a button and it does certain things. How do I see this for formal methods?
So that's another sort of application of the formal method, that when you have these formal requirements that express how your signaling system is supposed to work and how the safety of it and everything, then you can actually use that to generate this model that is in fact a computer program. Typically you have generic requirements of the signaling, and then there is some kind of configuration data that they should be executed for. So you have in the most basic form, you might have a track layout of an interlocking system, for instance. And then you have generic signaling requirements for the interlocking. And then these tools can actually generate a specific interlocking program based on the generic requirements and the configuration for this interlocking. Of course, when we move to CBTC, it all becomes a little bit more complex, but the principle is the same, that you have generic requirements and specific configuration data. And from that, you can build a model running on that specific data. And since this process is fully automated, and with tools going from the requirements to the specifics for the configuration data, you can try it out in a number of different scenarios in of different configurations and so on. And there you have both the access to formal verifications. You can verify that the requirements are met, but you also have simulations. You can actually both run predefined test cases, but also play around with the system and see that it behaves as you expect it to.
Interesting. I would like to change gears a little bit, and getting back to Andreas, you mentioned briefly that you had some, I wouldn't say issues, but you had some obstacles with your own colleagues in your own organization, that some people didn't quite see the point or the necessity in applying formal methods. I'm not sure whether I understood it correctly, but I could imagine whenever you introduce a new tool, a new methodology into an established organization, there will be some people that are resistance against this change that say, oh, we didn't need this in the last 50 years, so why would we need it now? Why do we have to change? So how do you see the challenges and overcoming the challenges of introducing formal methods into an existing Revit organization? I mean, you may be convinced that it's a great thing as like a champion or so, but how do you bring the rest of the organization along to say, yes, this is something that we want to do because of all those benefits that we believe we can achieve with that?
Yes, we have had a number of signaling or re-signaling projects in our organization, and they have, not all of them have been successfully. So we have a bad backlog, bad experience of signaling systems. It was difficult, it was time consuming, it was expensive, and so on. And then we also have a big willingness to expand our systems and so on. So we need to use a more efficient method to produce software for our interlockings. In this example, we have had a project which will expand the line to double track, and that that will also affect the signaling system, and we need more software in faster way, because it was a very aggressive time schedule for the expansion and so on. We started 2010 and it should be finished 2017, and we should have expanded the line to double track from single track. Earlier we have made all the software in a conventional way. It was handmade, it was reviewed and so on, and that was very time consuming. So then I contacted Prover and we discussed this, how could we make this in a more efficient way? And then I go back to the project manager and told them that, okay, you see how long time it takes to make the traditional software for the interlockings. Here we have a new method. I have done some calculations and find out that after 7 interlockings you will get a break even, and it will be cheaper than using the traditional methods. Are you interested? And he was. So I started to speak with my managers and get them on track too. And then we started. And of course, it takes a lot of efforts to reach these 7 new interlockings and do all this work. We re-engineer the complete line and lots of the old computer programs and so on to investigate all the functions and so on. It was a very, very big job, but today they take the work for granted because they are calculating the time schedules that we do. We use this tool, and signal are not longer the most or the biggest risk in the project. And that was a very big advantage for me. I see that this works.
Okay.
And the payback comes on top of the project. You get more accurate deliveries, you get deliveries on time, you avoid more replacement traffic, and so on. And that was the biggest outcome economically of this. But the signaling budget was, of course, strengthened and overused. But on top of the project, it was a very big advantage.
Okay. Yeah, I think that's the trick, that you need to find someone who plays along, who bears the risk of being innovative, like that project manager that you mentioned, And then, of course, it's up to you to demonstrate that this really works, that really gives the benefits that you were promising at the outset. And once it does, then it starts getting traction across the entire organization. Another question I have, how is this method adopted by the suppliers that you work with? Did you find that the suppliers are using formal methods already anyway, or did they have to change as well to adjust to the new ideas that came from your Revit organization?
Yeah, I would like to say that it differs a little bit between the different suppliers. They often use some kind of formal methods, but it was used internally for checking design parameters and so on, to check the software. But no, it was not used together with or towards the customer. So they often offer a traditional safety case with papers and reviewings and so on, lots of papers. But we have had experience of this too, because we have a refurbishment project on the metro with one of the big suppliers in the world, and they poke on me in an early stage and they say that you are responsible for the requirements of this. We don't take the responsibility for the requirements. That's yours. So I go into the archive and found the old requirement specifications. I interviewed the suppliers, which was very experienced of the system and has been involved in all the changes and so on so far. We have had the system in service about 20 years, but some of the changes was not documented. Then I go to approver and say, please help me with this to set up the formal specification of the system so I can take responsible for the requirements as they want. And I get the help, and we work a specification together. We set it up, and then these specifications was included in the contract with the supplier, and that was the first time it was so detailed in a high-level contract what should be delivered. It was no doubt of it.
Okay, good.
And that was a very good start for this. So now we are working with it. It's not finished yet.
Yeah.
But they were very positive to this because they feel convenient that we were sure about what requirements we have.
Yes. Suppliers usually like a client which is clear about their requirements. That's the case.
Yeah.
I think I'm about to come to a close here. I'm conscious of your time. I'd like to switch over to Gunnar again, who is probably a bit more suitable to answer this question. From what I heard from you two guys is that formal method seems to offer a lot of benefits of doing signaling projects, not just for modern technology like CVTC or ETCS, but also for existing signaling, understanding the old system better, the existing system better, and maybe even finding a solution for knowledge transfer from people who are heading towards retirement and the knowledge would otherwise be lost. Now, if I think that this is something that more railways should adopt, how would you see the journey to convince more railways to go for these formal methods?
So I think part of that relates also to this topic on standardization, because if we can have more standardized system within railway systems, we can also supply more ready-made formal specifications so that you don't have to start as much from scratch. So that's of course one challenge, to sort of bring down the effort needed if there is more that you can reuse. But also just sharing experiences between the different metros or railway operators, like this podcast, for instance. I think that can be a great help, because there has been a lot of work done out there, but it's at least today it's somewhat isolated in certain infrastructure managers that are doing this, and it's not that widespread. There are some initiatives, like within Shift Rail, this European Union project, that are looking into formal methods and are writing sort of a guidebook on how to apply them and spreading the word about it. So I think there's definitely more that needs to be done to make it more widely available. But in general, I can say also that I think that the technology and tools and methods are generally available. So it's more about changing mindset and spreading the word about it. And then I'm sure that it will spread more and more.
Yeah, and I mean, you touched on it. I would think and I would hope that this podcast episode here can help at least a little bit to spread the news and to get people to introduce to formal methods in the first place. I must admit, and maybe I've just been living under a rock, but I must admit that I knew very, very little about this when I heard about it. So now I definitely know a bit more, and I'm quite impressed by the potential benefits that you indicated. I think anybody who is listening to the podcast now knows at least somebody who is championing this on the client side, on the operator side, which would be you, Andreas, and also somebody which would be you, Gunnar, who is a consultant and a service provider in that field to basically give interested railways a leg up, even if they're not sitting in Stockholm, but somewhere else, and maybe starting with Copenhagen, which is probably not too far away anyway. So I'd like to thank you very much for your time and for your education of myself and also of our listeners about formal methods. I really hope that this gets a little bit more traction, maybe with the help of this podcast as well, because I think it seems to be a new method. Well, new, I don't know whether it's new, but it's for many railways, it will be a rather novel method of improving things, of improving the explanation of the existing railway system and also explaining the journey to a new system. And and hopefully that leads to a better quality in project delivery and also to a more efficient project delivery with regards to time savings, cost savings, because all of these things are quite hot topics in today's world. A major criticism for the ETCS rollout, as you probably know, and also for CBTC projects, which tend to become more and more expensive rather than becoming cheaper and cheaper as there's more buildup of knowledge. So thanks very much again, and and maybe we have a follow-up at some point in time, but in the meantime, all the best for the application in Stockholm. I hope that Andreas can keep convincing the organization to apply it wider and basically make Stockholm like a role model or a showcase for the application of formal methods. And for Gunnar, all the best that you can carry this important tool and this potentially beneficial tool to more railways, not just in Sweden.
Yeah, thank you, Frank. It was a pleasure to join your podcast.
Yes, thank you, Frank. It was nice to participate in this podcast too.
Excellent. So for all the listeners, I hope you enjoyed this episode. If you did, then just check out some of the others because they're all great in different shapes and forms. And do the usual things, liking, subscribing, downloading, telling your friends and colleagues about it, especially for this one here, because you probably took from this conversation that formal message should be spread out a bit wider across the rail industry. Thanks very much for listening, and I see you next time. Keep it simple and bye for now.